for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Hello, everyone, and welcome to today's webinar. From our Standards Activities Board series, today's topic is Ethics Within Systems and Software Engineering of Autonomous Intelligent Systems from the Software and Systems Engineering Standards Committee. My name is Scott Levine, and I am the Membership Manager at the IEEE Computer Society. Before we get started, I would like to address some housekeeping items. The webinar is being recorded. You can ask any questions in the Q&A box you see on your screen. The speakers will answer as many questions as they can following the presentation and during each person's segment. If possible, please reference the slide your question refers to. A copy of the slides and the recorded webinar will be emailed to you tomorrow. As more findings are discovered and put into practice, AI continues to change the way we live our lives. The IEEE Computer Society provides various opportunities to learn about the topic and discover more. For example, you can stay up to date by utilizing the Computer Society Digital Library. Our vast inventory of research includes over 100,000 articles related to AI. Amongst this inventory is the leading journal within AI, IEEE Transactions on Pattern Analysis and Machine Intelligence, which has an impact factor of 24.31 and a massive archive of peer-reviewed papers. Furthermore, you can connect and grow with other professionals via various communities, conferences, and more. More information will be shared with you after the webinar. You can also always learn more at computer.org. Joining us today is the chair of the Software and Systems Engineering Standards Committee, Edward Addy, who will lead today's discussion with Ali Hassami, Asghar Kuna, Matthew Silvera, and Ken Wallace, who are each a working group chair for a standard within this IEEE 7000 series. With that, Edward, the floor is yours to get us started.
Hello, and I join Scott and welcome you to this webinar. As Scott mentioned, I'm chair of the Computer Society Software and Engineering Standards Committee, as well as being a member of the Standards Association Standards Board. We're excited to talk with you today about several of our standards and projects. The IEEE 7000 series of standards is just one aspect of the IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems. And that initiative is itself part of a broader IEEE program on ethics called Tech Ethics. The 7000 series addresses ethical considerations in autonomous and intelligent systems with 16 standards either already published or in development across multiple societies in IEEE. The webinar today is going to focus on 4 of those standards that are associated with S2ESC, which is the name of the Software and Systems Engineering Standards Committee. IEEE 7000 was published in 2021 and addresses ethical concerns during system design. This discussion will be led by Ali Hassami, chair of the Computer Society Working Group that developed this standard. IEEE 7002 was published in 2022 with the scope of managing privacy issues for collecting personal data. This part of the webinar will be led by Matthew Silvera, who is chair of that Computer Society Working Group. P7003 is an ongoing project, so the standard has not yet been published. It has a focus of avoiding negative bias in algorithms. The chair of this, and again, this is another Computer Society Working Group, and this chair is, and will be leading this part of the session, is Ansgar Kuna. P709 is another active project to develop a standard in the area of establishing methodologies and tools for effective fail-safe mechanisms. This effort is actually under the Reliability Society rather than under the Computer Society, and is led by Working Group Chair Ken Wallace. However, S2ESC is a co-standards committee on this effort. We're going to conduct this webinar in two sessions with two of the efforts discussed in each session. The Working Group Chair will provide an overview of the standard and its status, and then I'll ask a follow-up question or two, and that'll be followed by questions from the audience. Remember, as Scott said, to type your question into the Q&A box, and then we'll do that then we'll do, two sessions with two standards each, or two efforts each. And at the end, if we have a little bit of time, we'll entertain questions on any of the standards and projects. The first session includes the two published standards, IEEE 7000 on ethical concerns during system design, and IEEE 7002 on managing privacy issues for collecting personal data. Ali Hassami, Director of R&D and Innovation at Vega Systems, will be presenting on IEEE 7000 and then having a discussion. And that'll be followed by Matthew Silvera, President of Objective Business Solutions. Now, notice I'm giving you just a very brief introduction of each of the working group chairs, but if you look on the registration page, you'll find a lot more information about each of the presenters, each of which has a very extensive and distinguished background, which led them into their chair position. Ali, if you will, go ahead and lead us with the discussion of IEEE 7000.
Thank you very much, Edward. My name is Ali Hassami, folks. I had the honor and pleasure of initially joining and eventually chairing, both as the chair and the technical editor of IEEE 7000, which became the core standard in the so-called 7000 series, as Edward has already highlighted. Just a bit of background that this was and potentially still is the first global standard for consideration of ethics in technology in terms of having a defined process for incorporation of ethical concerns during system design, and very much relates to ethically aligned design initiative that has its roots in 2015. In fact, this standard was initiated around 2015, and later on, when I joined in 2016, it was already in discussion, and we had a very sizable working group representing fairly large number of people across the global community. It attracted a lot of attention, and unfortunately, typical standard development life cycle being roughly 2.5, 3 years, this took 5 years, which probably is not so surprising, largely because ethics and technology are not good bedfellows in starting to conceptualize, and a global standard posed quite a challenging task, hence the 5 years that it took from concept to publication. In terms of a quick overview of the process, we started with a large number of processes and eventually cut back after, as I mentioned, 5 years of discussion, multiple versions and interim drafts. We homed in on basically a perspective that mostly concentrated around we do need an exploration stage for recognizing who are the stakeholders, etc., and what values do they hold, what is the context, etc., And then the traditional system engineering activities, so-called development phase. So in that particular order, the so-called concept exploration has got one process which looks at the concept of operations of an autonomous intelligence system with learning capabilities and the actual context of its application. So there is so-called ConOps area, as well as the specific context of application. And the exploration process here basically demands that we go and identify who are the stakeholders, specifying the scenarios in which the stakeholders, or not just the end users, engage and interact with the system. Once and capturing values, so-called ethical rights and values in a kind of a value register, and more or less moving on in principle to having identified the stakeholders and the specifics of scenario analysis of context of application, actually eliciting from these principal stakeholder groups the values that they believe are, in a sense, either fostered by the system of interest in the context and concept of operation, or potentially undermined. So we are interested not only what are the values of these stakeholders, but also whether the system of interest or system under consideration is actually interacting positively, promoting those values, or interacting adversely and undermining those stakeholder values. And you can imagine in a typical project, if we have one context for one of its applications, which could be cultural, regional, or industrial context of application, we would have a huge range of these values. Typically, probably many tens will emerge during this elicitation process. And the final stage of so-called second stage of our exploration as a process is what are the significance that the stakeholders associate with these values. So we want to have some guidance, and that's inherent in the second process of the standard. How do we prioritize these? Because invariably, similar to requirements engineering, we cannot address all the values in a system design, otherwise it would become completely unmanageable. Then we go into the so-called requirements definition, and then we have ethical value requirements, or EVRs. So similar to all other commercial, quality, performance, and technical requirements, we have now an introduction of a new form of requirement which has its roots in the identified stakeholder values. Once the requirements are captured from the ethical perspective and included in the, if you like, the large pool of other requirements, there would be invariably a degree of balancing and horse trading between a whole body of tens and hundreds of requirements. Whatever gets distilled out of that in terms of those which have to go into a system design, ultimately go into so-called ethical risk-based design process. So that this is the final stage, because the standard itself is only concerned about system design. It is not covering the entire autonomous intelligence system life cycle. So that is the final process in the IEEE 7000 standard, which focuses on how we take ethical value requirements, EVRs, and translate them into some form of risk-based design process to be included amongst many other requirements for realization and deployment, etc. We also have a process called transparency management that stretches across all our activities. And this is largely about being open and explain to the principal stakeholders and the civic society who are the basically the principal stakeholders here that have been identified, consulted, what are the values that have been elicited, and what are the priorities that the project has identified amongst these values, and how those have been translated into ethical value requirements. If I may just give you a quick overview of basically the principal strengths of 7000. It actually allows a system to be seen within an ecosystem rather than an isolated development. It actually is very sensitive because values originate from the ethical values have enormous relevance to the dominant culture and rights and history and even geography of context of application. And it deals with both direct stakeholders and indirect stakeholders, that is, those who are indirectly influenced by the outcomes of the system. And in the elicitation phase, the standard demands that both the direct and indirect stakeholders are encouraged to participate in the so-called elicitation phase. We have defined a few measures of competence in implementing this standard, and there is a key role called a value lead. And value lead is someone who basically guides the development teams and the senior management with the essential activities that arise from the processes of this standard. And we have defined value lead essential competencies. And indeed, since the publication of the standard, we are taking these human competency issues pertaining to implementation of ethics in technology seriously and developing what we call a competence profile for most of the key roles in the value-based system engineering, including the so-called value lead. But we sometimes refer to the practice of implementing 7000 as value-based engineering. So just to finish, the whole idea is obviously when you consult the stakeholders and come up with the points of contact of the system and impact of the system on their perceptions, on their sensitivities, social and historic sensitivities, we come up with a huge body of so-called values identified that we tend to cluster around what we call core values. So there is a kind of a implied hierarchy that come from what's called a material value ethics. We also use 3 moral philosophies and +1 in order to help identify these values. So it's not just question of here is the concept of operating the system, who thinks there is anything that upsets them, or are you enchanted about the way the system behaves in terms of your value basis. We use 3 fundamental philosophies, moral philosophies called utilitarianism or consequentialism, the virtue ethics of Plato, and the duty ethics of Immanuel Kant. And we also have accounted or allowed for additional local, spiritual, or historic or belief systems that may dominate the value system in any given setting or context of application. So technically, we have 4 tools available to us to utilize in order to elicit the values of the stakeholders. Then, as I've already mentioned, we have a value ontology based on material value ethics that basically takes a core value that is underpinned by what we call how we perceive that value, to value demonstrators. And then below that are features of the system that we have to design that, if you like, embed that value into the overall architecture. The values, as I have mentioned, are all also prioritized in order to both balance them as well as know what are more significant in the minds and hearts of the stakeholders, in order to be able to convince them that what is being designed is, at least in the event of shortage of or constraints on time and resource, etc., are the significant values closer to stakeholders' hearts and minds. So in a sense, the 7000 as the core of the 7000 series is a universal 5-process standard that allows ethics to be built into conceptual design. Just to finish off, this standard stops at system design, which means specifications and development of architectures in order to embed ethical values. And we are already contemplating extending the standard with additional substandard or standards that complement it to cover the remaining phases of autonomous and intelligent system life cycle aspects. Thank you very much.
Okay, thank you, Ali. A lot of what you indicated did not necessarily, to me, to be specific to autonomous intelligent systems, but actually generally useful for system design in general. Is that true?
It is largely true, but the focus of the 7000 series are in support of the so-called ethically aligned design, whose main purpose was concerned about autonomy and learning capabilities of algorithmic systems. But as you rightly highlight, if people are not dealing with AI systems per se, our standard is still capable of assisting them to elicit and build sufficient mitigation processes in their design to save and protect human values.
Okay, thank you. I'm not seeing any questions specifically here. Hopefully at the end we'll have time to come back if there are any additional questions. I would like to just mention there are a couple of questions in the queue about obtaining the slides. The slides will be mailed out tomorrow, so you will get a copy of the slides by email by tomorrow. Okay, we're going to move on to our next standard now. Matthew, will you take over to discuss 7002?
Yes. Hi, everyone, and thank you, Edward, and for inviting me to present the session. So we're going to talk about the P7002 series standard, the data privacy process standard, and specific, how does that actually apply to the day in, day out work of putting together a system with the ethics and the concepts around data privacy protections as they relate both to the business and, more importantly, to the end user, consumer, or subject. And as Ali pointed out, the 7000 series is coping with a number of things that aren't necessarily natural for an engineer or software designer to confront. But we put together 7000 to with practical examples, practical concepts, and fundamental guidance to allow the software engineer to cope with a number of issues that may sound at first foreign. More importantly, the standard's really designed to support a number of other international standards, including NIST, standards such as SP 853R5, and the ISO 27000 series, such as 27001. So this is what we're going to be chatting about in this session. When we think about common privacy issues, it's very important for us to understand the why. Why are we collecting the data? Is it for a specific mechanism to function? For example, is it a functional requirement? The machine won't work without this information. Or is it a non-functional need, such as collecting statistics for sales and marketing, perhaps? And then we have to understand the what of collecting the data. How do we go about collecting that data, and what does that data look like? And we'll go into a lot more detail about that. We're going to have to navigate a vast number of regulatory and compliance requirements, not just ones that we might be passively familiar with, but if we're going to take our product or service and market it globally, which is very commonplace now, we're going to have to understand how to navigate that and understand that perhaps one map to chart the course may not be the best approach. We'll go into more detail. And finally, it's critical for any product or service to have a successful product marketing and management strategy. And when those are disconnected from the product design and they're disconnected from the consumer's expectations, you generally do not have the type of product acceptance and may have product rejection on launch. And we're going to talk about how to avoid that. So what are some common issues that we confront when we talk about P7002? We open up this concept around consent. How does this end user consent to the collection of private or intimate data, whether that be their location, contacts, photographs, digital signals, devices that they may have interconnected to other devices to trace or allow them to have access, speech recording and recognition, and so forth. The next concepts we want to understand are what controls do we have in place and what controls do we have available to apply for privacy protection. A lot of times I'll be in conversations with design teams and engineers, and they'll approach me and say, well, wait, we have the solution. We'll encrypt everything. And then that way we've addressed most of the problems. That may or may not be the appropriate answer. And so when we think about controls, we want to think about the controls benefits and the controls disadvantages. Sharing. Who or what has access to this end user's private data? Now, there's been a lot of conversations about things that have been labeled surveillance capitalism and so forth. We obviously know that when we talk about an end user mobile device like a smartphone, that there's a vast amount of private data being collected. Are there partnering agreements that your company is engaging with that you need to inform the end user about? Are there partnering agreements that you need to be aware of so that you can appropriately comply with those technically? And those are also very important things to explore when we talk about the data privacy process. And then finally, we want to really understand how the UI and UX experience supports or inhibits the end user's control and notice and rights. A better UI and UX experience almost always leads to better outcomes when it comes to user acceptance about managing and handling and processing private information. So now we're going to chat about navigation of compliance and regulations. And we cover this as part of the data privacy process standard. And we cover it because it's critical to understand the context of where your product and service is operating, the context of where your end user is, the context of your partner, and where the data is. The IEEE, a partnering organization with IEEE, has over 740 different catalog laws and regulations that relate to privacy controls. That's a staggering number. And within those laws, there's an equal number of subsections and clauses and requirements. And I'm not even citing the number of other bureaucratic regulations that are captured by the IEEE. So when you're thinking about this from a software engineering and design perspective, you clearly need to invite your friends and compatriots of your organization into this and understand that there are a lot of commonalities. In other words, many jurisdictions have common use cases and controls that you can share. There are many, many crosswalks between things like NIST standards and ISO standards and GDPR legal requirements. But there are also many unique edge cases, specifically when it comes to managing, handling, storing, and forwarding of information that's privacy labeled. So when you're going through this process, you're going to want to understand before you start writing any code or any use cases, how these requirements matrix together inside of the larger design. And then finally, you should really challenge yourself and challenge your team about siloed thinking. It's easy to call up the Office of General Counsel or your legal team or your contracted attorney related to compliance and ask that person or that group for answers. It's easy to roll through a checklist of compliance requirements and say that you've done your job. And it's also easy to potentially go down the rabbit hole of saying that, well, you've allowed people to opt in or opt out with a universal acceptance agreement or consent agreement as they log into the app. That type of thinking will generically do two things. It will cause you to do unnecessary rework on your product and service to address privacy gaps and controls. It's also going to not bring to the table the best approach in terms of how to go about in meeting and managing these requirements. So finally, I saw this the other day, and as I've been busy dealing with a number of OpenSSL and Java patches for one of my clients, as we were going down the rabbit hole of new and exciting Java patches that came out in Q4, as I'm sure everybody else has, I saw this and had to laugh. But in fact, when we read the fine print of a number of requirements when it comes to acceptance or end user agreements for accepting privacy, we often think about it like this: too long, didn't read it. If you're seeing that, or you understand that that's the end game, you should really challenge your team to think about how to make that UI and UX experience meaningful for the user. And as they walk through enabling various apps on their device or various features, prompting them and explaining the why behind the need for their consent. That's really the end game. Informed consent is not a check the box yes or no. Okay, well, I think that covers the high level of what we want to chat about.
Okay, thanks, Matt. Yeah, let me ask a question. You mentioned privacy requirements and you mentioned design. Where in the life cycle should you start considering privacy?
you should start considering very early on in the conceptual phase, as Ali described it. And in fact, probably even earlier than that, and we describe that in our standard in terms of the ideation phase, where teams are busy discovering a go-forward plan for an innovative solution to bring to market. That's the best time. You may not have all the answers right then, that's fine, but it's good to start capturing what the questions are.
Okay. One of the questions that we had come in is, are you developing a recommended practice or a standard? And if it's a conformance standard, then how are you going to implement the conformance criteria?
A good question. It is, IEEE did approve 7002 as a standard, and there are a number of requirements inside of it. And the requirements traceability and the requirement satisfaction wasn't intended to be prescriptive in terms of thou shalt do this or thou shalt do that. It was to provide a framework that could be used and customized around business needs and around technical needs to meet the broader privacy requirements of individual geographies or regions or governmental standards.
Okay. Yeah, you've talked a little bit about it, but tell me a little bit about your experience dealing with that whole international landscape. That's got to be very interesting.
It is very interesting, and I'm working on a project right now, in fact, with the state of California and child welfare. And it's fascinating because we're using a number of multi-cloud services, including AWS and Google and Salesforce. And what we're finding is that when you think about the shared responsibility model that is often touted for security, there really is no shared responsibility model for privacy. That model is incumbent upon you, the consumer of that cloud service. And so what we've spent a lot of time doing is exploring data residency requirements, exploring data management requirements, and so forth, because we have requirements to be FedRAMP compliant, and that requires a lot of the data to be resident in the continental United States. So there's a lot of things to sort out there, and I work with a very broad team because clearly it's not a one-person job.
Okay, well, thank you.
Thank you.
Time to move on to our second session now. The second session will include the two active projects rather than than published standards. So we're going to have project 7003, which is has a focus of avoiding negative bias in algorithms, and 7009, which is establishing methodologies and tools for effective fail-safe mechanisms. Ansgar Kona, who is Global AI Ethics and Regulatory Leader at Ernst & Young, is going to lead the discussion on 7003. And then Ken Wallace, the Discipline Lead for Software Engineering for the Maritime and Land Divisions of BAE Systems, will lead 7009. So Ansgar, if you want to take over.
Thank you very much, and welcome everyone. It's a pleasure to be speaking to you all. So yeah, I'll give you a brief overview over what we are working on in the P7003 standard. This is a piece of work that we launched in 2017. So it's also going into the 5-year range that Ali was talking about. We are getting there, about 85 to 90% complete now, I would say. We're looking to move to balloting phase in the coming year. So what are we looking to do with the P7003? The title that we've chosen is Algorithmic Bias Considerations, and there's some deliberate thought behind the way in which we formulated this. For starters, we are talking about algorithmic systems as opposed to AI systems or machine learning systems, in order to highlight that many of the challenges, the causes that lead to bias in AI systems as we see them being identified in the media in cases where AI is deployed with bias problems actually also apply to other algorithmic systems that don't use machine learning or other AI methodologies. If we think, for instance, around bias that is introduced due to the data sets, well, if the data set in any validation approach that you're using or any testing approach that you're using for software systems is not representative of the stakeholders that will be impacted by the system, then that system will end up being biased. And as such, it isn't specific to AI. The other elements regarding a title is bias considerations, as opposed to elimination of bias or something in that sort, because we are focusing on understanding clearly where are you applying this system, and is the bias that you're having actually a problem, or is it part of the system doing what it is supposed to do? If we think, for instance, around automated systems that are being deployed in the medical profession, then differentiating between male and female sex may be relevant to the task and should not be considered an unintended bias, but rather should be an intended bias. So bias considerations is the focus of the work. So the stakeholders that we are aiming at with this piece of work is individuals and organizations that develop, deploy, or use algorithmic systems. So really across the life cycle of the systems. Obviously, the developers are heavily engaged in such questions as what are the data sets that we're using in order to make sure that the system is sufficiently performing for various different population groups. However, the user is equally relevant here in that the user needs to be applying the system in the correct context. If the deployer, the developer has created the system for one particular use case, then they can only produce the system in an unbiased or a bias appropriate way for that particular use case. If you deploy it and use it in a different use case, then none of the guarantees can hold. So the users must also take these things into consideration. So key questions when developing or deploying algorithmic systems that we are focusing on within this standard are questions around being clear that you understand who will be affected by the system. That is what defines whether the system is biased or whether the bias is acceptable. Who will actually be affected by the system? What are the decisions and optimization criteria that you are making when you are creating the system? Not all bias is related to data. Bias is also introduced by how you define what you're actually optimizing for in the system. How are these criteria justified within the use case for which the system is being created? And are these justifications acceptable in that context by those stakeholders that will be impacted by the system? So if we look a little bit at the structure that P7003 is following, it is intended as it's a process standard. It describes a process of AI system development, deployment, and usage. It is focusing on minimizing unintended, unjustified, and unacceptable bias, and does so by really looking at a number of stages that run parallel and interleaved with the life cycle stages of an algorithmic system. So while you are looking at the system requirements stage, so even pre-development work, you already need to be reflecting on what are actually the requirements for bias considerations. So do I understand what my usage context is? Do I understand what the value systems are within which the system needs to be operating, which is what defines what is acceptable or not acceptable as far as differentiating performance with respect to different kinds of input groups. Identification of stakeholders, both the stakeholders within an organization that inherently bring with them certain priorities, but also identifying the various stakeholders, either the direct users or those directly impacted by the AI system or the algorithmic system, or even indirectly impacted participants. How is this system going to have an effect on people and the society where it's being deployed? Is that effect going to have negative implications for some parts? And if so, how can those be mitigated? Data representativeness, obviously, bias caused by failures of properly representative data has been attracting a lot of attention in the public discourse around AI and machine learning bias. So this is a key element. Without a proper data set in your training, in your development phase, in your testing phase, you will not be able to identify whether the system is performing correctly across the different stakeholders that you've identified in the previous stage. Risk and impact assessments, clarifying what kind of risks does this system pose to different stakeholders that you've identified, what kind of impacts is it going to have, which needs to reflect back. Always everything is coming back to the central repository of the bias profile, and they, in that way, connecting each of these stages together. If you are identifying a certain risk to particular peoples, then does that need to change something with regards to the requirements definitions of your system, or does that need to change something with regards to the data sets that you're using? And obviously, any kind of a bias assessment, any kind of a process around algorithmic bias needs to culminate in a system evaluation phase where you're performing various assessments of the performance of the system to see how it is performing for each of those identified stakeholders, to see whether or not you are getting unintended differential outcomes in the system. So this is just a very high level kind of overview of the 5 core normative stages within the P7003 standard. So for each of these subdomains, the standard provides normative guidance around the decision-making process that needs to be made, the factors that need to be taken into account, and importantly, the way in which to document the justifications for decisions that are being made in order to be able to communicate, be it to the stakeholders or be it to regulators as regulation in this space is coming into play, that the process has been followed correctly, and in that way that unintended and unjustified bias is being avoided, or at the very least minimized as far as possible. And I will leave it at that and hope to address some of the questions that I'm already seeing coming in.
Okay, thank you, Ansgar. I have a question. I mean, this topic strikes me as both very technical and yet very broad. And I'm just curious as the background and experiences of, sort of generally across your working group. Who are the people that are involved with this?
Indeed, that has been one of the challenges of this sort of domain, that we need both the technical expertise that can address the question about how do we even assess these types of systems, but also the understanding about what are the challenges, where does bias come in, what are, for instance, cultural aspects that need to be taken in consideration. So as we set up the working group for 7003, we did make a deliberate effort to make sure that we have a broad and well-balanced representation. So we have a representation across industry, civil society, and academia with a reasonably equal proportion from each. We have participants with more of a computer science, AI types of background. We also have participants with a strong social science background that come in with understandings around how do different cultural norms come into play when we think about AI challenges. We also have participants with more of a legal background to help clarify how discrimination laws in different areas, sort of what the core tenets of these are, which could reflect on general principles that need to be considered.
Okay, thank you. There was a question that, they understand that 7003 is ongoing. It is, as well as 7009. And how could they collaborate? And I'll have a couple of slides at the end that actually indicate how you can indicate interest in any of these standards or standard areas, not only the ones we're talking about today, but in general, how to do that. So that'll be in the slide deck a little bit later. Another question I have, has the working group had any specific topics or areas where you really struggled with it just to reach a consensus on how to move forward?
Well, we've had some back and forth discussions when it came to this. How do we tease out different stakeholder groups and the relative positioning of internal stakeholders within the organization, sort of like management versus development teams and those kinds of players, as well as external stakeholders, whether we should be classifying these differently because they have a different level of ability to influence the way in which the system operates. So we had some lively discussions on that topic. We've also been having some discussions around how far can we go with specifying metrics or specifying particular methodologies. Until the largest, generally speaking, we have moved away from trying to specify very specific methodologies, but rather focusing on identifying aspects that need to be assessed, simply because the field itself, on the technical side, is developing so quickly that if you specify specific methodologies in the standard, it can very rapidly become outdated or no longer the best method that should be applied to the newest algorithmic systems.
Okay, and you may have just incorporated the answer to a question that was written. Can you mention which tooling is useful? So it may be more the types of tools as opposed to which tools.
Indeed. So we are not trying to say use this this particular tool set. We are happy to, and in some of the informative annexes, we will be referring to things like the OECD's site that is tracking AI fairness tools. But what we focus on is to identify that you need to be doing an assessment that checks how is the system performing for subcategories. You need to be making an assessment that checks your data set, including the robustness when it comes to the subcategories of your groups, those kinds of questions. But we won't go into the specifics or the particular tool that is most appropriate for doing that particular check.
Okay, thank you. And we need to move on now to P7009. So Ken, can you take over?
Thank you very much, Edward, and pleasure to be with you. Last but not least, so P7009, and as Edward said, this is slightly different in that it's joint sponsored by the Reliability Society and the Computer Society. It started back in 2017, and if you take yourself off to the website, have a look at the PAR, which is a project appropriation request form, what you'll find in a slightly longer version is what you're looking at on screen. And that really talks about the scope, the need, and the stakeholders. Now, this was written back in 2017 by Nick Gao and Alan Winfield. So Nick was the chair, the inaugural chair of the working group, and Alan started off as vice chair Alan's also involved in the wider ethically aligned design initiative and was also chair of Piece 7001, which is all about transparency in design and the like. So I took over being vice chair back in 2018 and became the chair in 2020. We had a 2-year extension at the beginning of this year. So we've got 12 months to run effectively. So a little bit like P7003, we've got another year to get through and get a balloted version. And we're on track to get basically the draft of that ready for the end of this year and move into getting it through the whole draft process next year. In terms of the overall approach, it is, as it says there, it's very much a practical technical baseline of specific methodologies and associated tools. Although I should say, just to manage your expectations, we're not talking about explicit software tools, for example. It's more how you go about using tools in terms of developing and designing particular types of design. How do we do all that? Well, for starters, it's a basic standard. So if you're at all familiar with safety standards in the main, you might be aware of things like Type A standards, and this is what this one's intended to be. So it's a foundational standard. What we decided very early on in the working group was that because context is so critical to what fail-safe may or may not be, that actually trying to be prescriptive in any way about specific applications, domains, or sectors just wasn't going to work. So it's all very much about being, as it says there, a basic standard, and really being able to give those who are going to adopt the standard the tools to work out what fail-safe means for their particular application and their particular context, and then being able to go away and do an implementation based upon their understanding, their knowledge, their expertise of their particular context. Safety engineering has been around for a good number of years. There are very many approaches to it, not all of them complementary. So what we wanted to do wasn't not try and reinvent the wheel, but to augment and enhance existing standards and to play nicely with as many standards as possible. So that's both safety engineering standards, but also wider engineering standards to kind of like fit in the whole ecosystems of engineering standards that's around, be those things like 15288 and 12207, which cover software engineering and systems engineering standards, but also to take account of the emerging standards like, for example, 7000 that Ali's already talked about. So we wanted to do that. So we wanted to be able to give something to engineers who already knew what they were doing, had established practices and approaches, and say, well, here you can work with this on top of, rather than have a revolution. But equally, we wanted to be able to signpost to those who are maybe exploring terra incognito, because actually there are some areas of novelty to do with autonomous systems and the like, some signposts. And that applies as much to the developers as it is to other interested stakeholders, like, for example, regulators and those interested in it from a legal perspective. We had a big debate about what actually autonomy means. In the end, we kind of landed in the position that said, well, autonomy is a continuum. The actual title of the standard is Fail-Safe Design for Autonomous and Semi-Autonomous Systems. And we're trying to work out what's the differentiator or distinction between semi-autonomous and fully autonomous. So in the end, we decided that really autonomy was a continuum. It has some distinct characteristics regarding it relative to non-autonomous systems. And typically, they'll be all about the ability to, as it says there, adapt via learning to their surroundings and their situations. And that's the reason why you would use autonomous systems to a certain extent in situations where you might not think about autonomy classically. And therefore, you've got the problem that you start to get behaviors which you cannot understand or know about in advance. And that's really where the distinction between autonomous systems comes from those which are maybe classical and a lot more deterministic in their approach. And then the second part of all of that, and we start to talk a little bit about values, albeit that if you go and look at the PAR, you won't see the word ethics in there at all. And that was intentional on the part of Danit and Alan when they wrote it. But the whole notion of not having validation of the consequences of action, of what the actual autonomous system does in advance of it actually doing something. So the other aspect of it, and again, I come back with a question you might ask, Edward, is what were difficult areas? Well, one of the real difficult areas was the foundations. What do you actually mean by safety? What do you actually mean by things like consequent and risk and things like that? as I said earlier, there is a lot of established existing practice out there for safety engineering and associated engineering areas, and everybody's got their own definitions, everybody's got their own terms, and unfortunately they don't all align. So one of the big challenges, and the group spent a lot of time trying to come to a place where there was commonality of understanding and commonality of definition. We got around a lot of those problems by avoiding giving definitions. We give descriptions instead, and basically turn it over to the adopters of the standard to recognize a particular description and how that relates back to a definition they would understand and they would wish to use in their context, such that we don't get them to change, because the more you get people to change, the less likely is they're going to use the standard or wish to adopt the standard. So if you give them a mechanism to actually say, well, I recognize that concept and this is what it translates to in our language, and everybody understands and agrees that language, then they can thereafter go and work with that language, always being able to refer back to the original description that is in the standard. So that was a fairly significant piece of work that's had to be done. We've got it ground in now, and it's really helping to move forward into the remainder of the standard, which does then essentially boil down into a couple of processes, one of which will be embodied in the actual autonomous system itself, and another one which is related to the whole regulatory context that such systems will operate in. And that is supported by a set of system requirements, which effectively are functionality which we are indicating to adopters of the standard they must in some way meet. We are not prescriptive about how they meet it, but in some way they must satisfy in order to be able to claim a conformant approach and design for the particular system they are developing. So, recognizing time, and we're just over, I will close with one final thought. A lot of this appears novel, a lot of it is very new, but it's always worthwhile remembering, particularly in regard to things like safety. Those who ignore history are doomed to repeat it. And unfortunately, one of the lessons of safety engineering is that all too often that happens. I've happened to choose this particular example of two accidents which happened almost 30 years apart. But actually, when you look at them, when you analyze them, when you look at how they actually arose, they are remarkably similar, despite all the learning that came from one, the one on the left, which has been extremely well studied since it happened back in the 1980s. You still get to see the lessons of it not necessarily being embodied when people come to do new things. That is one of the reasons why a standard like 7009 hopefully will find use amongst adopters. And at that, I will leave it and hand back to yourself, Edward.
Okay, thank you. Could you mention what is the status? Do you have a time frame for when you expect to publish the standard?
So the aim is to go to ballot next year, 2023. We have one remaining year to go, so we have to have it all done and dusted by the end of 2023. And at this point in time, I would say we're on course to achieve that.
Okay. Were you talking about mechanisms and general structures? Is it always possible to return a system to a fail-safe condition, or is that something that might not be achievable?
No, that's exactly why, for the sharp-eyed amongst you, you might have seen that at the very bottom line, the very bottom bullet point, when it says fail-safe design, it's not an equates, it's an approximate capable of preventing loss of freedom from an unacceptable risk of harm in the event of failure. No system, no design is entirely invulnerable to failure. What standards can do is, and P7009 certainly has that intent, is it can push the limits out further such that the system is a lot more capable of withstanding problems and failures without failing unsafely. But you can never abolish that entirely. There will always be a residual level of risk that such systems carry. And one of the real points to try and bring home in the standard is to get people to understand the notion that there will always be a residual risk, and that just because you claim conformance to a standard like P7009 doesn't mean that your system is entirely invulnerable to failure, and that failure may or may not be safe.
And IEEE standards, usually in the boilerplate at the beginning, indicate that type of thing of any standard. We don't guarantee, even if you use a standard, it's going to be, everything's going to work out well.
Indeed. And in fact, actually, we had quite a healthy debate very early on, particularly some of the computer scientists, those from an academic background, were very keen to stress the availability of guarantees. And there was another school of thought, and I include myself in that, which basically said, look, we understand what you're saying, but we cannot be in a situation where we're offering anybody any guarantees whatsoever, because not only will IEEE legal department not agree to that, but actually we're giving the wrong impression, and we really need people to understand the fact that actually, although we're trying to make sure the system is fail-safe as it possibly can, there is a limit to that for the reasons I've already outlined.
Okay. One of the questions that has been written in, what is the perspective on fail-safe versus fail-secure?
Well, that's interesting. Fail-safe, one of the things we highlighted fairly early on was the need for things that can't be changed easily. And we landed on effectively trusted computing base, or a variant thereof. For those of you who are familiar with it, trusted computing base is essentially the little bit of the system which has to be able to ensure that all the rest can go off and do whatever it wants to do in whatever manner it wants to do it, without itself operating in an inappropriate manner. Now, that largely stems from security considerations. And essentially, when you start to look at it, security and safety become very much the two sides of the same coin. One of the areas we've been using, or one of the techniques we've been using to develop 7009 is very much evidence-informed, and looking at a lot of literature to see the kind of mechanisms out there that have been historically used. And if you go and look at that, and we will publish it as part of the standard, at least that's the intent anyway, what you will find is there is as much information there about security and all the mechanisms that come from that as there are about safety. And basically what that's essentially telling you is it's all very much the same problem. I know they're two different communities, because I have to deal with them in my day job, come at it from very different perspectives, but ultimately they're trying to solve the same problems. And one of the things about 7009 is effectively trying to come at it from the perspective that says, well, if you're trying to be safe, you also need to be secure as well, because you can't be safe until you've got a level of security in there.
Okay, thank you. Okay, well, I am not seeing any other specific questions. So we can move into if anybody has any questions about any of the standards at this point. I've actually got one that sort of is general for each of the four chairs. There have been a couple of questions already about, well, how do I get involved? Are things ongoing? I'm curious as to how, what motivated each of you to get involved in the efforts you're currently leading. So Ken, you're already online right now. We'll go back to the others, but what motivated you to get involved with 7009?
So my motivation was pure curiosity. Way back in the dim, distant past, I was involved in neural networks back at the tail end of the 80s, beginning of the 90s. I then went into industry and kind of moved away from it, although I continued to collect my monthly editions of PALMI, as Scott talked about. I was interested in seeing how things had developed. I also deal with safety in a professional capacity at work as well. So again, I was interested in it from that perspective. But I have to say, it was largely curiosity driven. I joined as just a humble member of the working group, never expecting to end up being asked to chair it. But that's what happens when you join these kind of like groups. So I'd encourage people to join as much as they possibly can. It's well worth it. But just be aware, you may get more than you ask for.
One of the questions are there any drafts of 7009 available? I would assume the answer is no until you actually go out to ballot.
Well, so the draft will be, so the way we've done it, I don't want to bore people with technical detail, is that we're producing draft technical notes. They then effectively will become the basis for the draft, and that will become available, the draft technical note, the latest version of it, which is the one that effectively, hopefully, we will agree to push through to ballot or very close to it, will be coming out very shortly. So if anybody does want to get involved, there is still a little bit of time. You best contact me directly or come via the system where you can register your interest in the standard, and then you'll be most welcome to participate in, to a certain extent, what hopefully is the closing leg of it, but equally we welcome diverse views and opinions and things like that.
Yeah, and obviously is available to members of the working group, so you could join the working group. Okay.
Exactly.
And there's a comment, I understand you cannot give guarantees, but to some extent the standards might be able to assure a given level of function or failure with given probability. And I would say no. There's again.
So again, we had a huge debate and discussion about that. If you get your hands on the draft version of it, you will find that probability doesn't get much of a look in, although there are those who would argue it should do. We talk about likelihood instead. And we work on that basis because, again, it is possible that some applications you will be able to probabilistically characterize, others less so. So we work in terms of risk and likelihood and consequences, as it says on that slide there, not in terms of probability. That doesn't mean to say that adopters of it might not then subsequently agree that for their particular application and context, they have sufficient knowledge that they can actually work with a known probability distribution.
Okay. Ali, what motivated you to work in 7000?
I wonder if Ali's gone. He was having to go fairly promptly.
He may have. He had another meeting, I know. Matt, how about you?
Thanks. Yeah, what motivated me was I work with a number of clients in the healthcare space and in heavily regulated compliance spaces such as telecom and banking. And so as an IEEE member, when I saw solicitation of interest come out for this, I joined P7002 specifically because a number of groups I was working with were struggling, frankly, to develop a process that demonstrated they had a controlled approach to managing privacy in the design and implementation phase of their product or service. So I joined the work group and then eventually became the work group chair. I think probably following along the path of Ken, and it's been very rewarding and fulfilling. And I'm still involved. We're coming up to work on some new parts for 7002.
Okay. Ansgar, real quick, what motivated you?
Well, for me, I was working as a senior research fellow at the University of Nottingham at the time on a project regarding bias in recommender systems and how people engaging with those understand what their concerns are. So when the global initiative on AI and autonomous intelligence systems was launched and 7003, that topic was being broached as something that required a standard, I became interested as just from the point of view of translating the research findings that we were getting in our academic environment out and communicating that to the ecosystem of people applying algorithmic systems to the real world.
Okay. Well, thank you. Thank you to people who have joined. Thank you for the working group chairs who did the presentations. The last two slides are, as I indicated, some more information. Here are some indications of how to get involved. You basically go to my project and indicate an interest. And I've listed the interests that would be a part of what the presentations today or the projects we've talked about today. And if you don't have, you have difficulty working with that or have questions about it, you can send me an email at the email address there, and I will try to point you in the right direction. And then I also have on the last slide some links for the IEEE program on ethics, the overall larger program. So Scott, back to you.
Awesome. Thank you, Edward, and thank you, Ali, Matt, Ansgar, and Ken. A fantastic presentation. A lot of great insight and knowledge shared on a very current topic. Quick programming note. If you've joined us before for any of our webinars, or if this is your first one, we have 3 webinar series. This one, the Standards Activities Board, the Build Your Career webinar series, and the Distinguished Lecture webinar series. Our final webinar between all 3 programs is on Wednesday at 11 a.m. It's from our Build Your Career webinar series, and the topic will be Conversation with Senior Management with Roger Granis. Be on the lookout for the 2023 schedule from all 3 programs. Those should be announced in the coming weeks. Again, thank you for everyone for joining us today. Big thank you to Edward for leading today's panel. And thank you again to Ali, Matt, Ansgar, and Ken for sharing their great insight with us. Have a great rest of your day, everyone.
Thanks, folks, and bye.
Thank you.
Thank you, everyone.